also have started the recording the session, so we'll have the session recording available like we did for the other sessions. So what we have done in here that in your laptop or in the lab computers, you can just go ahead and all apps or the programs, right? And you can search either by name or by the software. So what we're going to do is that you can write it here, the Mathematica. It will show you that this is the Wolfram Mathematica. Okay, so you'll find it here, Wolfram Mathematica. So what you need to do, you need to go in program menu, right? And either you go by browsing. So you let me go and browse in here, so I can search all apps, right? And then start. Yeah, but you can still find it here. You will find it there, that Wolfram Mathematica. So if you start looking at the new site, you'll find it here, something called you see that? Wolfram Mathematica, right? So if you click on this, what you see two tabs, and you will see it in any version of the Windows that you have. One is called the Wolfram Mathematica, the other one is called Wolfram Mathematica kernel, right? So we have to click on Wolfram Mathematica, not the kernel. So please notice that. Okay, I can come to each of you and see. I stop the recording now. I mean, resume it. So once we do this, we have this window will appear to you. Now what you can do, you can always have things which are as if I wanted to start from scratch. So I've been using it. So I have few files of mine which are available, like you do in Word. But I'm going to do what? I will create a new document. So this is how it appears like a new document. Now, this is a platform. Now, you don't see anything, right? But I would suggest you a few things that you should do to make your life easier. And we are hoping and we are believing that that with this session that no one has any background in computing. So we are going as if from no background from computing needed to use the software. So I would suggest few things that would benefit all of us in using the software. So do you see there are tabs? File tab, edit tab, insert tab, format tab, and there's a tab called which you are not seen in other software, but in here called palettes. Okay, you see that palette? You click on this palette. Once you click on this palette, you will see there are a few assistants that you can find in here. And Mathematica has been used significantly in classroom teaching as well. So that's why you can see the classroom assistant. Okay, fine. I can come to you. So yes, I'll come to you. So what we do, we click on this basic math assistant, and if you click on this, see it becomes an available one of the tools. So I'll stop the recording now and then come to each of you and see the recording again. Now for few of you, you might find that Mathematica will open. So in that case, see I opened a new file, but if you want to open a new file, what you need to do, you need to go in file menu and click on this new. And you will find it here, the notebook. So actually Mathematica, like Word and Excel, they have file format, such as the document is the doc is the file format for Word. Mathematica has the file format of NB, notebook, .nb. You can see that's called NB, .nb. Okay. So far now we are quite clear, right? We are on the same page. Now I like to start with the Mathematica, which gives you very basic things that we can do with the Mathematica. One of the basic things you can do with the Mathematica is you can use as a calculator if you want to. Suppose if I want to multiply, say 6 and 7, Mathematica is quite intelligent that I know when the two numbers are written next to each other, they are basically multiplied. So if I press space and if I write 6, see it automatically type cross sign. And if I can make it bigger, so I can make it 150. Is it clear to everyone? Yeah. So maybe make it 200. Is it clear to everyone? So what I did, I wrote a number. Okay. Now the easiest thing you can do in order to find the answer in Mathematica, you just click select the line that you want to evaluate, and you go in evaluate and say evaluate cell. Yeah, you can click it. But I'm going a route which people can do by clicks. So we are not asking people to use the commands. So if I click on this, you get an output. See, so in this case, what you're going to get? Input, IN. And it's a interactive software, so it's interact with you. So what it does, basically it gives you gave an input number 1, it gave an output which is output number 1. Okay? And this is a simple methodology that has been used in many software. You don't have to compile to get an answer. So you cannot compile and you can get an answer. So this is the philosophy which is called Interactive Developing Studios. Yes? Have a question? Okay. Is it clear? Now let's go for a little bit advanced things. So what we do in advanced things, if you see this is the numbers, right? And you click on this called advanced, you can see there are a lot of stuff that you are basically would like to do, right? So if you click on this list advanced, it's gonna get you to the places now. Now since we are using Mathematica for our undergraduates, so I like to tell you a route which you can take and get an answer of your desire in a much quicker fashion. So instead of remembering any command, we like to do this. And this is one of the fastest way of getting to an answer. You click on this, right? On the line that you see this, you see that after the output you see a line. Always in Mathematica you'll see a line with a plus sign. You click on this, right? If you click on this, you see that format free and Wolfram Alpha Curie, right? Okay. Okay. Now both are pretty much similar, but actually Alpha Curie does a little bit more. And I tell you that why it does more. Suppose I like to go with the format free. And what is the meaning by format free? That the moment I click on this, you can see this, the equal sign came with a red dot. So suppose if I want to take a derivative of anything, like we used to take in our courses, right? So I want to take a derivative, I don't have to remember any command. I will write in a plain language. So what I'm writing is a derivative of, and tell me the number. And this time I'm going to type it from using palettes. So I'm not going to type myself. So I'm going to type it, say that this is the fraction sign, you can see this fraction, right? If I click on this, what happens that a fraction appears and I can write it here, the x, okay? And then I can write it here, the x square. So the moment I write it here, square, I have to go here and find out where the square is. This is the 1 square. You can see it, superscript, right? And if I click on this, then the square sign appears. And if I put equal sign, and then what I do, I have to click outside so that I can write it. See, the problem is that the power still is on, right? You have to do what? You have to just press this space and arrow key and you can put it down if you want, right?
How did you get drifted?
Sorry?
What did you get drifted?
To get what?
Drifted.
No, I just wrote a derivative in writing. I have not calculated derivative. Now I'll calculate.
Calculate everything. How did you get the sign here? What did you click?
Oh, okay.
I'm sorry.
That's okay. What you can do, you can click on this here. Okay. You see that format free? This is the one.
I think it would be clearer if you close this place.
Sure, I can do that. No worries. Yeah, sure. See, I highlight this, and we are doing without using any keypad. So we are just doing by clicks. So we go here in evaluation tab and say evaluate cell. And the moment I do this, it starts evaluating. And the problem of this, it takes a while because Mathematica has to understand what did you do as a command. So I give a command and I got an answer, right? But is it the one that we look for? You usually want to see an answer which you want to see the details of the answer, right? This is an answer. It's not a detail. You want to know what is the detail of an answer. So in order to get an answer with detail, what we're going to do, we will do the same thing. Again the same thing. See, I have the line. Okay, I click on this and say Wolfram Alpha Curie. And if I do this, see that there is a different sign appear. Equal sign, but there is a static. All the way star. And then I can write it here, derivative of, and again I use the palette, so I need to create a fraction, so I write it here fraction. I write it here the x, and then in the bottom x square, right? So I wrote x, and then I say that this is the power key. I say it here is square. Okay, and then I can put equals. Now see what happens if I do this. I click, I highlight this, and go again in the evaluation and say evaluate cell. So each writing is a cell. So see, it is evaluating, and you will see the difference of the two evaluations.
So Doctor, we
So
it knows by writing the exact word derivative of without any spelling mistake, right? That's how it knows.
even if you do mistake, it will capture it.
No.
It's quite good. But if, for example, if I were you, if I had a mistake, what I'm going to do, I'll write it in Word and see what's the spelling mistake the Word notifies me. Or I can Google it, okay? And I can just cut paste. So you don't need to memorize this. Do you see that what outcome that we got in here? Significantly more, right? Why? Because Wolfram Alpha Curie assumes that you are planning to give this one, and that's why it believes, and that's why it gives you the first time, the derivative. But it also gives you alternative things, right? So you may ignore them. But the most important thing that you should realize in here, that this is the derivative, right? And if you click on this, you see that step-by-step solution. So it gives you all the solutions which are possible. All the derivative which is possible in here. See that? So much detail that you can see, and you can.
All the answers are possible, or the steps? All the steps.
All the steps. You can see each step is written here. Suppose if you wanted to take a look at it, each step is written here. So this is the fraction, this is the derivative. Okay, and then what we do? We do the quotient rule, right? And this is the answer of the quotient rule. And then each step, derivative of x is 1. So this is the box has been created. What has been done? The box has been created. And then simplify the expression. And then you take the derivative of this, which is the box being created, right? For you to notify. Derivative of 1 is 0, so it is writing, giving you all the details which are possible. And then you again use power rule, and this is the final answer. So this is quite good that it can give you a final answer of basically with the whole tutorial that you can use for your analysis, right? Clear? Any question here? As in here that integration. So what I'm doing, the first topic that we covered is the integration, and this is the topic number 2. Okay? And then again we do the same thing. There is nothing very fancy in here. You have this math assistant, you can write it here, and then I can do what? If I want to write an integration, I'll again follow the same logic, do the same thing. Click, and then Wolfram Alpha, right? And then I can say, okay, anybody would like to give me an integration that you like to solve? Say integrate. Integrate what? We can say it here that integrate, and if you wanted to integrate, you can write it here and say that integrate. The moment we had our same function, we said x, right? And then we say what? Say x square. So we have x square, and this time we say plus 1, for example. Integrate. That's it. This is the one I want. And if I want to know what I'm trying to do integration, I can say it here, suppose by writing that this is what I want to do integration. So in that case, I just click on this button, it created me the whole thing. So I can write it here, the same expression here, I just copy paste, so save my time. I just go here, so it pastes it, right? And then instead of variable, I can write it here, the x. So basically this is what I want to calculate, right? So I can compute by highlighting this again, the same step.
If you, let's say, compute x squared plus 2y.
Okay, fine.
So how will find which variable you want to integrate?
Fine, we can address that. No problem. So this is what we're gonna do. Click and say evaluate cells, and this is how it's gonna evaluate things for you. So this is an answer to this integration, right? Okay, and if you want to have an answer of detail, what happened in detail, this is the detail. If you want to click on this and you like to know the details, this is the detail. First of all, it classifies an indefinite integral. Why? Because there is no limit. So it's indefinite. So the possible intermediate steps are these. So this is the integrand, it's substituted by this, solved by this, and this is an answer, you tend it back, this is an answer to this question, right? And it does a lot of other things for you, hoping that you may look for this as well. So like I said, as a proactive in terms of providing you information that you may not be looking for, but accidentally you won't find useful.
How can we delete it if you want, like the answer?
I go in the palettes, right? I go in advanced, okay, and I have this, right? So I have this x, and then I have to write the fraction. So this time I'm going to write the same fraction, but on purpose I will put y. And the y is no longer a decision variable in this case, right? It's a constant. So I can click on this, right? And I can say evaluate cell, and it's gonna evaluate it for me. But it didn't give you the details, right? It didn't give you the details. So if you want details, again we can do what? We can go here and click on Wolfram Alpha, and then I say that this is the thing I like to solve. So I may copy the same thing and see, I'm trying it for the first time, let's see if it works. So I'm gonna and see what happens in this case. So it's solved actually, okay? It's solved. And you can see step-by-step solution. If you like, you can get an answer. All the steps are given to you. Okay, this is the question. I want to integrate by limit. So again I highlight this, evaluate cells, and it will again evaluate, but this time it's gonna take the limits. And sometimes you work with the limits.
Because you wrote down 2 to 4.
Yes, 2 to 4. And I can write it by either sign like this, or I can write by words. I choose by words so that people don't get confused. I mean, the easiest way of possibly writing the things. So this is the way you can find out. You can see the details. And as I told you that the Wolfram Alpha Q reports you a lot of other things if you are interested to take them. But this is the information that you like to take, so this is the information that you have on top. Coming back to the graphics, I think Mathematica is one of the top softwares in terms of producing the graph. The only problem is that if you are a LaTeX user, the size of the graph is larger, and hence it is harder to take it to the PDF file in terms of size growth. But other than that, it's quite fast. But I believe that most of you, if you are using Word, it perfectly suits that. So the thing that we like to do it here, suppose we like to plot, and in this case, we again click on this, and again, as I told you that what we do, we again say this is our item 3, right? Or topic number 3, which is plotting. Plotting is one of the powerful tools of Mathematica, so we have to understand that there's a lot of power in there. I would rather start with the plotting, say very simple plot, and say format free again, so I don't have to remember any format. If I do, I say plot x is equals to 2x. So in this case I say this is the function 2x plus 10 from where 0 to 10. So this is what I am giving you. So I am asking that plot this function from 0 to 10, and by simple plain language of English, right? Nothing command has been given. So I click on this and say palettes, I say plot, say evaluate, and see it does the plot. So it does the plot for you within no time. So it's a very powerful data, right? It is also very powerful in terms of providing you 3D graphs. It's very powerful, and I will show you in a minute that what can be possible in this. Suppose most of the graphs nowadays, they require to be dynamic, because you want to see what change has happened, you want to change some parameter, and you like to see in real time how the picture has got changed. So what we're going to do in order to avoid this, in order to achieve that, we wanted to go here, copy the same command. So we copy that. Okay, and I click on this line, again this plus sign. But click on this, say Wolfram Alpha Query, and this time I'm going to say plot this. And see what happens after I do the plot. So I click on this plot, evaluate cells, and this time you can see it takes some time, but you're going to see what happens in this situation. So it is running the plot for you. My suggestion, one more thing as an advice to you, keep this off. You don't make it on. If you need it, you click go and make it on, right? If you don't need it, click it off, because it basically diverts your attention from the main results to this. So this is the plot. So if I click on this, see what happens. Now, what we can do next, you like to see what happens if we do a 3D plot. So this time I'm going to give a number and say Wolfram format free. I'm going to say plot, in this case z is equals to 3x plus 2y, okay, y x from 0 to 10. And y from 0 to 20, and see what happens. Now notice here how many dimensions we have in this question. We have x, one dimension, we have y, another dimension, and we have z, which is an output dimension, which is third dimension. And in this situation we will highlight this and we say to evaluate. So this is the plot C. Some of the issues that we have to understand in here, that some of the commands that you may have to provide, you have to see whether you got an answer or not. So personally I use command to generate this, so I didn't use it, but I can see what happened, why it didn't work for us. So I can again copy paste, and it's a good experiment, this, see why it didn't work for us. So we copy this, right, and I go here and say Wolfram Alpha Query, and then again paste it, and then see if it works for us. Otherwise I'm going to tell you by the command that how I can generate that. So this is the plot that we got in here. One more thing people would like to do is this. Usually you have seen in mathematics a lot of functions, right? A lot of functions. In real life, a lot of functions. So how to create a function which is a very simple function you like to evaluate for? Mathematica provides a very good support of creating any function that you want to create. So suppose a very basic function I like to create, I say f, like I used to do, right? And say it here that f is equal to, like I am writing the function. See, I say that this is, and I use the palette in order to avoid any memorization of the command. So I say that this is, actually I have to remove my cursor first. Okay, I brought it here and say the x square. Okay, and then plus 1. So this is my function. Is the function complete? The question is here, it is not as complete as we have to decide. The only new thing that we have to do in here compared to what we used to do is to declare Mathematica who is variable. So what I'm going to do, I'll put in Mathematica there is no round bracket. So when you create function, you have to give the rectangular bracket. Okay, and then I do what? I put it x, and this is the variable that I've declared that in function this is the variable, like I used to do in mathematics. But one more thing that you have to do is called put this underscore sign to declare Mathematica. The moment I put the underscore sign, the color has got changed. Meaning what? This is a variable and the Mathematica takes it as a variable which changes with the function. So like I can do it here. And one more thing, people do it here. Perhaps you would have to understand one point, that suppose you declare A and B. So if A is equals to B, the B value was 10, and then if it changes to 20, the A should also become 20. But that only happens when you do dynamic assignment. So what we do in this case, that in order to create the function that this is dynamic, we'll do this. And the moment I do this, see, it became green and it became green. So now the function is ready to go. So function is ready to go. Now what we need to do, we need to recognize the Mathematica that this is the function. You highlight this and say evaluate. So this is the function being evaluated. Now you want any number for the function, you can put 0. Okay. Okay. This new. So you put it here x underscore, and I put it here the delayed sign. And this is what you call delayed assignment. Delayed assignment meaning what? Whenever the x value changes, automatically the new value of the function will be calculated. So it's not going to be static. It will change. Every value that you calculate for x, the function is updated. So let us take a look at it, this function. We had this function, right? Now if you go and evaluate and say evaluate cell, it is evaluated, right? And now what we're going to do, we'll look into this and say that what we're going to say. We say here, huh? Yes, I want to do it, but I want to show you that how it calculates for you. So this is this is the value of x, right? You go evaluate cell is done, right? And if you want to put say F100, it's going to calculate 400 for you as well. Okay, so it computes the number for you. Now one thing people would like to do sometimes, that to plot this function like Dr. said in here. So we can do it here and say plot, format free, and say plot f of x from where? From 0 to 10, or say 100. So this is the function. Because Mathematica, I have declared this function, it's in the memory. So I can do this, evaluate cells, and see how it does. Okay, I'll look into this issue of why it didn't work for us, but I can tell you that how to do the plot command in here. So suppose if I want to plot, I'm going to write it here, the plot. The moment I'm writing this, you can see this, the plot has appeared. Click on this, and then I would put my function. This is the function, right? Okay, where the function value is x, and the x value takes from where? The x takes a value from 0 to 10. And if you want, we can also, obviously you can email me and I can tell you the set of commands that you require to do. So if we do this, this is the plot. I usually do plot by command, so it will be the case that my knowledge of using this format field might not be very useful. So is this clear for you? Right? Now what we can do more in here, that since we have exposed ourselves to the commands, we like to go here and then do one more command in here. You know that we like to do and see how the 3D plots are happening, which are very powerful in this case. So what we can do, we can say it here that plot, and then it says 3D, and it's a very powerful plot that you can do. And on purpose, I create a function which is more often used in our analysis called log function, suppose, or exponent function. So I create a exponent function, I say x, okay, and then I say that we like to go for log function again to the y. So these are the two outputs, right? And then I say that x goes from where? From say 10 to 100, and the y goes from where? From 20 to 200. And we like to know that, so what we are plotting a function of 2 dimensions, right? So what we do, we click on this, say evaluate cell, and you can see that the plot has been created. within no time. Okay, so this is about the plot. I have to search it up for what is the easier way of doing this, but currently I do it by the command. But commands are also not difficult to work with. Actually, Mathematica is a very powerful in terms of help. So we click on this 3D plot, and it gives you a lot of functions that you can see, and you can take them and apply them, any of these. So I purposely did not take them, but you can take any one. For example, if you want to learn this, I'm going to say, okay, I want to learn this. So I like to plot it, so you can just copy this, right? Copy this. So I just copy this, and then you can bring it here in Mathematica and say paste, and this is pasted, and you again highlight this, and you can say that evaluate this cell for me, and it evaluates for me. So it is not the one that requires you to have any programming skill. You can take this and customize it, the graph that you want to plot. Okay. So now with this, we're going to move over any other topic that we left with. We said the differentiation is covered, integration is covered, plotting is covered. Now we like to go for the last topic of the discussion called topic number, I believe 4, right? So basically optimization, but you can say it here, it can also be a maximization and minimization. Usually when we do this, we are talking about having a unconstrained optimization where there are no constraints, right? You can optimize any function that you want to. So one of the possibilities of a function that you like to optimize is this. Suppose I have a function, a very simple function I create, and I create the function. One more thing that you should keep in mind is that, see, suppose if I write f, okay? Mathematica, whatever variables that you gave, it records in the system. So suppose if I give an f and I want to know what is f, so I want to know evaluate cell, and it gives you an outcome that this is an f. And if I am not sure, then I can put it, I think, in question mark sign and see, this gives me the value that what is f. So give me the value that in the system, it is recorded as a global variable, and this is the value of the function. Okay? This is the value of the function. And I can say, okay, fine, then I would like to go and say that Wolfram F query and say maximize this function. And see what happens. I haven't tried it, but I'm trying for the first time, and see what happens. Maximize this. So I'm just asking Mathematica to maximize this. And I go here and evaluate cell and say, so palettes, and see it maximize or minimize. What happened? See, it says that no global maximum found. Okay, but we can try some other functions if you want to. But what point I like to make it here, that remember that what we did, we put a question mark and ask who is f, because you may have a duplication problem, so you have to avoid that. So one of the ways of clearing is that you can go here and say clear. The moment you write clear, see, it gives you a lot of commands that are possible. And one of the commands is called clear all. So you go here and say, this is the function which I had, delete it from the memory. So what happens that it deletes, and it's a very good practice. Whenever you start any programming, delete the variables which are in the system. So otherwise, one way of deleting the system is also another way, I'll tell you, but this is the way. Now the question is this: if I put this question mark and f, see what happens. I say that who is f? Global f. That's it. But no declaration. So this is what keep in mind that how to do this. Now we create a function. Typically we use with a quadratic function to do this. So again I create a function like I used to do. I go here and write a command for me, maximize, optimize actually. Optimize a quadratic function. It can check for you, actually. It can check for you.
Or it doesn't tell there is no global.
Yes, it will tell you. But actually we are doing in this way, like we are not using any programming tool, we are doing a very basic thing and asking to solve for us. So quadratic function I gave, I know there is a global maximum or the minimum, right? I know it for sure. So that's easy to find, but for the difficult functions which are high dimensionality, you have to go for the Hessian analysis, Hessian matrix analysis, which we are not covering, of course, in here. So in this case, what we're going to do, we'll write it here. I'm doing it for this time like as if we are writing. So what we're going to write it here, we say that 500, say x, and in x we put it here what? Square, right? So we have to go there in the basic and say the x has a square, and then what? Plus what? Plus we can say it here that 5000x plus say 160,000. Okay, a simple function I wrote. I don't know necessarily what will be the answer, but let us formulate this and see if it works for us. So we can evaluate this cell. So this is the function value, and if you want, you can calculate a number. Suppose if I give 10, what happens? I'm gonna get this number. Okay, so function is ready. And if you want to know what is a function, the Mathematica also can help you. If you just press this equation sign, meaning what is that? And if I ask Mathematica to evaluate, it evaluates and gives me the number. But the point is not this. We know how to create the function. We like to maximize the function. So we go here, click, and say format free, and say, in this case we know particularly that this is the minimization, but in most cases you know what you're doing. You're maximizing or minimizing. So I say in here minimize. In this case minimize f. In this case, right? So let's see if it works for us, but I will tell you the other way which is possible if it did not work for us. Okay, so this is the input outcome that we got in here. Alternatively, we can always solve this problem using derivative methods, which we have already addressed. Otherwise, there is a function called, if you wanted to go over, we call it here the n, and you can say it here maximize. So this is the function, n minimize and maximize, if you wanted to go for details on this. So I think we will not touch them, but if we need it, you can always write me an email or contact me. I will be happy to assist you on using particular command for maximization and minimization of a function.